Good day, folks. Let's look at this question. It's a system. It's Newton's second law, which is it's not constant velocity, it's not at rest. Let's read the statement. It says two blocks A of mass of 5 kg and B of 2.5 are connected by light inextensible string. A 30 Newton force is applied at an angle of 20 degrees to the block B as shown in the diagram below. The applied force causes the blocks to accelerate across a rough. That rough means there's a friction floor which has a kinetic coefficient of 0.25, right? So guys, this system, it accelerates this way. We choose right as positive, and we have given the mu k there, right? And this object is pulled at an angle and not this one. So the force applied is applied on this one, and there's a friction in both. So what is not the same here is the friction here. The friction between the surface of these blocks is not the same, but what is the same is the mu k there. Guys, let's look at the forces there. We have a normal force, we have a gravitational force, we have a friction, the Fk, and we have a tension there. In this one, we have a normal force, we have a gravitational force, we have a tension, we have a friction, we have a force applied. Of course, in that force applied, there's an Fx, and then there's an Fy. There are components there. Very important. In this one, in block A, the normal force is equal to the gravitational force. But in this one, the normal force is not equal to the gravitational force only. Since it's pulled, it's going to be a normal force is equal to the gravitational force minus the Fy. Very important, guys. Now, I'm going to leave the state of Newton's second law. I'm going to straight to 2.2. Go straight to 2.2. Now it says calculate the magnitude of the frictional force acting on the 5 kg. So let me calculate it here. It's 2.2. It's Fk times Fk is equal to mu k times normal force. We're gonna use that formula because we have an Fk, we have a mu k, we have a normal force, so we're looking for that. So the mu k is 0.25 with times by the normal force. Remember, I said the normal force in the 5 kg is equal to the gravitational force, so it's going to be 5 times 9.8, and when you punch that in the calculator, it's going to be 12.25 newtons to the left, right? The frictional force is going to the left there. Now let's go to 2.3. It says draw a label free body diagram showing all the forces acting on A and block A. So since I've done the forces there, so you can just use that, right? So it's gonna be an object by dot. We have a normal force, we have a gravitational force, and we have a tension. It must be straight lines, guys, and Fk there, right? Okay, guys, since we are not asked, I'm gonna do the free body diagram of the block B. This is block A, but I'm not answering the question. So block B, the free body diagram there, it's gonna be a normal force, a gravitational force. I'm gonna do the one that is in the one that has components. We have Fx and we have Fy, and then we have a tension force, and then we have an Fk there. That's very important, that free body diagram. So the answer here is this one. It's 3 marks. So we're going to have that and that, and any of the two, right? And 2.4, it says determine the acceleration of the blocks. So the acceleration of both blocks, guys, is the same, so we'll do that simultaneously. What is the reason for us to do it simultaneously? Is because we do not have the tension, but we will ask the acceleration. So I'm gonna say block A, and then F net is equal to ma, right? And then what are the forces acting on block A? These are the forces. So we choose right as positive, so we have a tension that is positive, and the Fk that is negative is equal to ma, right? The tension is unknown, and the friction we just calculated, it's 12.25. It's 12.25 equal to 5, the mass, and the acceleration is unknown. So we're going to have t is equal to 5a plus 12,25. This will be equation 1. So we are creating an equation there. I hope that makes sense. Now let's go to b. B will say F net is equal to ma. What are the forces acting on B? Here are the forces that are acting. We have a negative tension and a negative friction there, right? And the positive Fx, right? Let's start with the Fx. We'll say Fx is positive and minus Fk minus tension is equal to ma. I hope it makes sense by that. Now let's substitute the Fx. The Fx, what is the force, is 30. The force is 30 and the angle is 20. So we're going to say 20 cos, no, it's 30. It's 30, the force, cos 20 degrees, minus the Fk of the 2 kg, of the 2.5 kg block, which is block B, we haven't calculated. So we can calculate by saying the Fk using the formula that says mu k times normal force. The normal force, it will be mg f sine theta, right? So let me put it in the bracket. So it's going to be, the mass is 2,5 times 9.8, which is the mg, minus the f sine theta. The force is 30 sine 20, right? I hope I make sense by doing that. And then we have a tension there. And then we have a tension is equal to 2.5a. Right, let me show you again. This is Fx, 30 cos 20, and the Fk, it's mg. Since it's pulled at an angle, it's going to be mg f sine theta. This is the one. And then minus t. We don't have t in that case. Right, so we can just leave that as equation 2, right? We can leave that as equation 2, or you can just punch this in the calculator. So I'm going to substitute equation 1 into equation, I forgot this. This is what I forgot. I nearly forgot it. So let's move this to the side and move this to the side. So this is mg f sine theta. We forgot the mu k. The mu k, it's 0.25. So it's 0.25 times that. So when we substitute, so it's going to be 30 cos 20 minus 0.25. I'm rewriting it again. 2,5 times 9.8. Minus 30 sine 20 and minus, and then the t, we have two terms there. We have to put them in a bracket. It's gonna be 5a plus 12,25 equal to 2.5a, right? So when you do the math here, which is punching this, right? And then this is going to be minus, you minus with that. It's going to give you an answer that is 70. It's going to be, and this is going to be negative, right? So this is going to be, I'm not going to rewrite it again, guys. I'm not going to rewrite it again, this whole thing. I'm just lazy to punch it in because it's going to be -5. This is going to be this and this and this. -5, -12,25 is equal to 2,5a, right? And then when you take that to that side, this 5 to this side, it's going to be 7,5a. And then remember, you punch this in a calculator and then you minus this. It's going to be the answer. It's going to be already calculated that, guys. It's going to be 12,38, and then you divide by 7,5. The acceleration is going to be The acceleration is going to be 1,65 meter per second square. That's the acceleration there. Guys, you just need to punch this and get an answer there, which is I don't have. I just did it in a calculator and do it all. So we have the acceleration there. That's it. That's the end of this calculation. I hope I made sense. Cheers. Bye.